Hello, this is Mbatha. I'm going to present my project number 2 of Computer Science 334 project. Um, so what I'm going to do is to go through the rubric and then show and actually demonstrate how I implemented each and every one of the features that are actually supposed to be marked. So the first one, so if I go to the rubric, is the login or register, and then authentication tokens, all root protected, unique names, passwords, information stored in database. So the first one that I'm going to actually tackle here is all routes are protected. So what I'm going to do is that I'm going to go to the website which actually hosts my web page. So which is um, project2 cs334.adns.net. So this means that the website is actually hosted online. It's hosted on the Amazon web cloud solutions. Yes, so it's actually hosted in a container, so everything's web hosted, with regards to the specific project. So that is the link to the project. So when I do that, it goes to project 2 and on employees, and it's logged in already. So let me just log out, since I actually logged in previously. So well, it's logged out now. So now, since it's logged out, I'm going to demonstrate the first thing, which, like I said, is passwords. Sorry, it's actually all routes are protected. Um, the first one, let me just bring this, you know, all routes protected. So I'm going to cancel that. So I'm going to demonstrate that if I have not logged in, none of these routes will actually go in. So if I go to search employees, it redirects me to log in. If I go to employee graph visualization, it redirects me to log in again. And when I also go to view graph, social graph, it also redirects me to the login page. So that's basically what happens, because like all these routes are protected. Only this routes are protected, and we can tell by actually going in those routes. If you go to login, it actually takes you to login, and when you go to register, it takes you to register as well. So if you log out, I've already shown, I can log out of this information. Now, secondly, now I want to register, and then um, I want to go to the site. Then from there, register. So, and my registration username, I want to use my serial number, which is going to be 222.18521, and then my password, I'm going to make it. So now I'm also going to demonstrate the password. Like here, I'm showing that my student number is my student number is my username in this case, and the password is supposed to meet a specific criteria. So it's supposed to have at least one capital letter, one small letter, at least I call it like one special character, and it should be at least 12 characters long. So I'm going to actually type a password, which I will actually just say skmb dot 12. So this is supposed to have all of them, capital letters, small letters, special characters and numbers, and it's supposed to be 12. So 1 2 3 4 5 6 7 8 9 10. So let me just try to register that. So I see here it says please match the requested format. Your password should be at least 12 characters long, containing at least one small cap, one large cap, a small number, and one of the special characters. Let me just go there and add two characters, and then let me just go remove, let's say, the numbers, and just use this. So it also gave me an error. So let me use numbers and remove the small letters and use capital letters only. To give me an error. So if I use small letters only, not capital letters, so it should give me an error as well. So if I actually now use the full qualifying password, it's supposed to allow me in. So the password criteria has passed. Now from there, it takes me to a login screen, so I can use the very same username that I used, just my serial number, and then from the password, which is KAMB, that now I can log in. Right? It actually asks me if I want to save it, so I will save it. So, but this is now logged in. I can see that I'm logged in here. Okay. Now from there, well, I'm going to show that I can log in. So yes, I did log in there, and that should be login or register. So that is the login and registration over there. So now I want to also show that after logging in, my information is actually stored on my database, my registration information is not on the database. So I've been playing around like with this for quite some time. So there should be other entries which are available in there. So if I have to go to the database and type select everything from the user and I reset that, I should be able to see my student number there, the authentication key that is provided to me because I logged in, and the password there that I used. So I didn't actually apply a hash key on the password. I mean, well, I'm storing the password in the database. Okay, so it should be safe, I guess, unless if there's much going on it. So okay, after this, now the, the first and second criteria should be done. The first and second criteria should be done. Now I am going to go to authentication tokens. So authentication tokens were also implemented using JWT. So what I actually really have here is that well, I'm going to open this file, my coding environment, and show how this is implemented. So when you actually open the actual project itself, which I'm going to try to open from here. When I open my project, I mean, already I have demonstrated that like the project is working quite well, and an authentication works quite well. So for JWTs and for authentication tokens, I would like to show also here that when you go and log in, for instance, now, well, there you go and get your username and your password from the form data. From there, you go there and actually check if the person exists, like in a database. And then at some point, if the person doesn't exist and you want to log in, it goes there and generates like an authentication token for them. So it goes there and actually updates this information. But oh, sorry, it actually generates the authentication token using this. So it's actually authored encode authentication token, and it's encoded like with the username. Now, please note that the usernames are unique. I will demonstrate the uniqueness later, but it actually generates a username. Okay. Now from there, after generating a username, I know that okay, fine. Using usernames that are unique, I will always have like different authentication tokens for different users. So that's actually how I implement this. And then from there, this is actually authentication in code, authentication token. So I have that in authored pi. So where I actually encode this using that, and from there I actually just construct a payload here with the user ID, and then from there I encode it like in a JWT format. So I notice actually this JWT contains information about the user, and I can be able to actually go and decode it by using this function, and then from there be able to get information about which user I'm actually like referring to at the moment. But the thing is, I actually replaced this based on the instruction document. It said that well, when a person logs in, they should be given a key, and whenever they actually try to access this key should be checked. So what I do is I save this key in the database, and from there, like I did show the database here that the key is stored in, okay, and the key is stored in the database here. And then when the person comes and tries to check again and tries to access anything else like after this, now this thing will be checked. But what I check for is I check for the availability of this. Note that this thing is unique. So if I check for the availability of this, automatically it links me to a specific user. So I can be able to go and check who actually like I'm actually accessing here. I don't have to go there and check who or which user I'm actually looking at here by decoding the string. So I can just check this thing against the like against the database. So when the person logs out, I actually remove this specific. So I'm going to demonstrate that as well, saying that I'm going to go there and actually log out. So after logging out, I'm going to go back to my database. Um, I'm going to go back to my database and actually request this information again. And you realize that the authentication token is gone on the user himself. So that should be it for authentication tokens. Um, that should be it for authentication token. Now, for unique usernames, previously I have registered on the website with my student number. So now I'm going to go and try to register again and say 222.18521. And then I'm going to use a different password. Uh, let me try to use the same password actually as before and try to register. Now, the system will actually throw an exception, an error, saying that it already exists. So username already exists. Please try a different username. So this already showcases and shows that the usernames must be unique. So the system will not allow anyone else to register if the username already exists and has been used before. So passwords, that has already been implemented and shown. So well, in the database. So it's actually compared like the database as well. So here it says information stored in database that has already been also well, I can say, demonstrated. Now, the second part of this test will actually show like the end-run data and the cleaning process and all the other information related to the section of the report. I mean the section of the requirements. So data cleaned. Yeah, here it's just mentioned that the data should be cleaned. So I'm assuming that this actually has to give information about like how the data was cleaned and the cleaning, like the cleaning process and actually like the output file. So what I'm going to do to first explain here is that I was given a raw data. So I actually used the CSV file which was given to us, and from there, in the CSV file, I did some cleaning procedures which I explained in my report. So that cleaning criteria which I decided to clean, I put it in code using Python pandas, and from there I actually processed the script. But now, first of all, the problem is that the first time I actually tried doing the cleaning process, I tried importing the script in Excel, and from there also tried inputting the script in Python, but then like both actually gave me problems. They didn't want to import the script because like it was very big, and they didn't want to import the CSV file because it was very big. So I had to come up with a plan to actually make sure that it's small. So I actually wrote a Python file. I wrote a Python script called I wrote a Python script called, let me check that. No, sorry, it's in data cleaning. So I actually wrote a Python script called email partition. So I opened the email partition in my Visual Studio Code. An email partition literally just goes there and takes emails or CSV and then partition it by using, I just go there, open this thing like a normal text file. Then from there, read like this number of lines, and from there, write in a specific file called result while I'm incrementing the account. And then from there, I save this into files. So this actually happens to be 100 megabytes. So this is 100 megabytes. So I save 100 megabytes of files, So I save 100 megabytes of each and every one of those files. So since my emails.csv file is actually approximately 1.4 gigs, so the total number of files that I actually get from this is approximately 15 files. So what I'm actually going to do now to demonstrate that well, with this information, I can be able to go and actually process this file. These files are actually very much smaller than the 1.4 gigabyte file, which will be opened in either Python or Excel. Now from there, after partitioning the data, I actually now am going to apply a cleaning procedure on all of those parts which were provided and like initially produced, which are all of this from 1 to 15. These parts were actually like the raw and clean data parts which actually have to be cleaned. So furthermore, I actually wrote another script which basically I call cleaning.py. The py has already been open in my Visual Studio Code as well. In the cleaning.py, here it is. It counts from 1 to 16 and then takes each and every one, sorry, from 1 to 15, and actually takes each and every one of those files and actually then applies a cleaning procedure. So here I actually explained everything that I'm doing to all of those files until this thing at the end produces a unified file called cleaned in-run dataset. So what it actually really does is that it, it okay, what it really does is that it breaks those into partitions, and it goes there and cleans bits and partitions. And from there, it actually then takes the cleaned files and then combine them into one file. And that's exactly what I'm doing here. I go there and then concatenate all those files, from the first one. So I read the first one, and that is the basis. From there, I take from the second. I concatenate to the first one, and then from there, I do the very same thing all over again. So but these are now the clean data version of the files. So I take one file, the big file, I partition it, I clean each and every file. After cleaning, I create CSVs, and from there I merge them into a data set. So in this, I've got 271 megabytes. Okay, the cleaning criteria, like I said, it's actually shown in my report. Now, from there, the data is cleaned, of course. Yeah, I mean, the data is cleaned. Now, from there, I actually show that, okay, fine. Well, okay. On top of that, after cleaning this data, by the way, the way in which, like, the format in which the data is at this point is not ready to be used in my databases, like, or stored in the databases. So what I actually do and what I did here was I actually wrote another script called create my SQL table data. And then after doing that, after my with my SQL table data, I actually apply regular expressions, which is the very same strategy I use to clean my data. I use regular expressions to extract each and every one of those information here. So I actually define regular expressions, which you can actually look up from my code under the create my SQL table data.py. And from there, I just run this and like I actually wrote Python code to apply this and then produce like all the files that I need which are compatible with my table information or my table schema. So I maintain three tables for my relational database, which is actually like the emails, employees, and recipient table. So now for this table, I actually generated like separate files, which are actually CSV files compatible with like the MySQL and the way in which I actually import my data into MySQL. Now from there I produce them. So this script it actually takes all the clean data, which basically takes this one file, and from there goes and mines for this information and create the CSV files. And here they are. In the project, these are also attached inside like the data and in scripts folder. Okay, so this actually shows my data is clean. So this contains clean data, which is actually ready to be imported into MySQL. Okay. Now, furthermore, I'm going to also show stored in relational and graph database. So I take this information and now store it in my relational database. How I actually implemented this thing was I actually used Python again. So now I actually had to use ORM. So which I'm going to also look at this. I use ORM. I use SQL Alchemy to actually connect to my database, and then from there load the data in the database. Create and like basically I will create tables, and from there load the data into the database one entry at a time. So what now I did was I wrote code, and the part of the code that does that is actually in the base. So, but basically, database depends on models of Pi. So, models of Pi is this file which also depends on SQL Alchemy ORM. And then from there, what it does is it actually defines my schema. It defines my tables over there. This is a definition of my objects. So, employee, message, recipient, and user. And here is a definition of the tables using my SQL function table and all the fields that I actually required to define those tables. So I defined 4 tables. So this is called an imperative mapping, in the SQL Alchemy ways of actually defining a connection between an object and a table. So I use the imperative mapping format. Now from there, after I have an archetype, I have an array value, I have everything basically which is actually attached to all of the tables, and from there I map them with the objects themselves. Furthermore, now I go to the database. Now I connect to MySQL server or database. I connect to that, and from there I make a session. I actually make a session from there. Furthermore, now I use this one session to actually do all my transactions. So from there, I actually go there and implement the load employee data, which is gonna be like a while loop, a for loop loading my information into that. Secondly, I have load message data. Thirdly, I have load receipt data. So this reads these files. It reads these files: SQL employees CSV, SQL email table, SQL receipt table, and then from there loads this information inside my relational database. So now I can show my relational database has populated information. To prove that my data is indeed loaded, I go to project mail data. I click on the I to get more information about this. So I realize I have I have a table count, 4 tables. The size is like 186 megabytes, and from there the tables, here they are. I have an employee here are the columns, and then here's the information, and like the tables. Here you can see the number of rows, and the average row length, and all the information relating to this. So it shows my information is loaded. So um, this I think actually completes the criteria. So data cleaning should be fine. ORM, I did use ORM, none of this, and information is stored in the relational database and graph database. Now, I want to show something. Now, with the graph database, I use Tiger Graph Cloud, and with the Tiger Graph Cloud, okay, here it is, it's ready. With cloud, I actually can also show that, like I actually have my data in there. And something very interesting with the Telegraph is that if I have like logged in, or if I have actually been able to import my data into my SQL, I didn't have to go to Telegraph again and reload or create loading jobs from scratch. I can actually literally like import schemas from SQL or from my relational database, which is SQL in this instance, by using this migrate from relational database. So I can go and actually load data and click on load data. Oh, sorry, that should be underlined that. So it should be load data. When I click on load data, there should be interesting information provided also on the side of how much data my system contains. And here I can see that my data is loaded already. I've got message, I've got employees, recipients, and I've got all the files which actually loaded the data inside there. And from there, I have all the stats of my information over there. So here it is. And that should be good. And that should prove that my data is actually also stored in my graph database. Here I'm gonna query on employee returns correct data. So thing like my data cleaning, I realized like there's quite a number of names which have been appearing in the cleaning process, and one of which like I mean in Excel when I was viewing this, one of the first people who will actually appear in the list is Ellen. So I'm going to search Ellen, and from the propagate from there, and I see that okay, but the top five most people are actually I'm going to go back to my website and now start searching since I've logged in now. I'll register. So I cannot register anymore. So let me go back and try to log in again. By the way, I'm logged out. So let me try to log in to the previous account again. Um, 221851. So I'm gonna log in again with the previous account. Yes, I'm logged in. So search employees. When I click on search employees, now it allows me to go in. Search an employee. I'm going to type Ellen. I'm gonna search for Ellen. And from there, as I search for Ellen, I will see the top five most people he contacted, which are Matt Smith, and then it actually shows on the system that this guy contacted up to 206 people. This guy contacted up to 206 people. Then I also have like this guy called Chris that I've seen as well. And Chris also, I think well he did contact some few people. Then there's Kim. Let me just take a random person. Let me take Mike. Let me take Mike from this and search who he sent emails to. So when I run this, I realize, oh, he actually sent emails to these people, but these people are none of the employees which are actually in the company. So I can go and check some of these people because some people actually did not send emails. Now, I go and check the emails. Now it says search not found. The requested employee doesn't exist. Please press the back button on your browser to go back to the search page and verify that the search key is spelled correctly. So that's also like other information. So you can also search for Smith, which is one person which I also like came across as I was busy doing my searching. So I realized that there's also Smith, there's Amanda, so there's actually like nice information to be aware of. So it's also like in the criteria for us to actually be able to use either the name or the surname to find the employee. Okay. So I'm going to actually do something very interesting. I'm going to actually get the surname of Ellen. So after going to my database and running this query, I realized that, oh, if the first name of this guy is Ellen, his last name is Philip. So we have seen that in the previous request, after searching for Ellen, we also get information about how many emails he has sent in total. In the script, I didn't get time to be able to implement like the periodic, search. So, but this only shows the total number of like emails sent, which is 206. So I see this is Ellen and his surname. I can also add his surname and say Philip. Um, is it Philip like double L? I think it's double L Philip. So yes, it's double L. Philip with double L. So if I go in search, oh, sorry, I don't get that. Stay here, Ellen Phillip. If I search for Ellen Philip, um, if my system is fine, I should be able to still get those 6 people or the same people who have been contacted. And if I only use the surname as well, the last name, I should be able to get this guy, Philip. So I see Philip sent 206 emails with the same people that he has sent emails to. So just shows the versatility of the search, either by using the first name, the last name, or both. Okay. This marks out this the query on the employee returns the correct data. Query on employee returns correct data. So I'm going to just assume that this is fine. Now from there, we also have filter for number of emails sent in time or period of total. So like I said here, I was only able to implement total. So I don't know how much this is gonna be. Is it gonna be 1 mark or 0 1? But I only implemented total, not the periodic one, because of how my data and how my data format was actually used from when I actually did my data. So when I actually had to go further and work with the database, I realized, oh, the format was supposed to be in a specific way, which I didn't actually take it off. So I didn't have enough time to go back and actually fix it. So, but anyway, I was supposed to actually just like bring the like the data in the right format. Okay. So the in-run data section for this project is actually quite set and it's fine. It's perfect. Now from there, there's actually a general criteria, which is the look and the feel, the styling. I think that as I was going to the website here, one is able to see all this, bits and pieces and all the lovely. I think I would like to actually mention the user interface, the colors of the table. We saw when the table is returned, it's got very nice colors, vibrant colors. Like the errors basically show. Let's say, for instance, if I try to go and log in. Let's say if I try to go and log in the 222.185.1 and then from there log in using wrong credentials. If I try using wrong credentials, this thing will say wrong password, your password is incorrect, and then please try again. While I have this thing, I usually realize that here this thing contains nice messages, it reports well, and the colors also are compatible, meaning this you can be able to see like what you're trying to see here. So the background color is not too bright and kind of like conflicts with the foreground color, so they're actually like very compatible. And also, the website is quite structured quite nicely. You can see all my divs are like nice, and I've got like my links here positioned nicely, and here's my header and information about the login is actually also reported here, and I put a separator here for like login stuff and here for for functionality. So yeah, that's literally what it actually is. So I'm going to go there and calculate out the look and the feel, the styling, and from the video submission, that's literally the video that I actually am I have now, and from there the web application hosted. So yes, the web application is hosted online, like I've shown that my actually project is hosted on project 2 cs334.ddns.net. That's where my project is hosted in total. So that literally completes my part of like video presentation. So when it comes to graph visualization, I actually did show in my report what I actually would have done and actually what I actually was supposed to do. The problem was that now I did not have enough time to be able to implement all these algorithms. But then I actually like gave a method of which I was supposed to implement them. I had a plan already. I read on Tiger Graph. I read on GSQL. I did some problems on them. I actually did some preparation. I did load my data on the Tiger Graph. I was able to install and actually able to start using Tiger Graph, but then I just couldn't be able to, finish off this whole task before the submission date. So because I was working alone, so the knowledge of how to display this information also on the front end using deep.js was also like something new to me. So I had to like take time and read all those things, and find out. So I gave the information of how I was gonna actually go about doing this, even if I did not actually implement this in the project. So I was not able to implement this for the project. So hopefully I'll be able to get a few marks for implementing like the links, because I actually did write the forefront page, which was supposed to receive my data or my JSON data from Telegraph. So I have just like a sample graph here, which displays initially if no data is received. So for the social graph and for all the other ones, I received this the user interface and everything is there. The graphics are there. The only problem that I have is just it's just that I did not actually apply the functionality itself. of being able to see the actual thing that I'm supposed to see in this. So also for visualization, and I go in there, you can choose your algorithm, and from there be able to actually get the right data. But like I said, I didn't have enough time to implement this. So, but hopefully I'll be able to get something out of this thing. Just for the information which could have been done if I had enough time. So this is basically it. This is basically everything that I need to represent. For more information, please contact me on my student card. I mean, on my student number and my digital information. Yeah. So anyway, this is like the video for submission for my project, and I'm gonna put this on YouTube for it to be accessible publicly. So yeah, thank you so much. I really appreciate this time and like the opportunity to be able to present my work. Thank you so much.